Hello Internet, welcome to another installment of tutorials from memory interfacing with microprocessors. In this tutorial, we are going to interface memory chunks. That means smaller memories but in multiple quantities with a microprocessor. Now this is a typical example of question that is put up whenever memory interfacing questions are framed. Now what happens is, in the previous tutorial we saw that 8085 is capable of interfacing 64K memory, but in case we do not have a 64K memory with us, but instead we have 8 ICs of 8K memories that sum up to 64K, then how can we interface that, and how are memory addresses generated, and how do we actually give or assign memory addresses to different ICs of memories. So this is going to be discussed in this tutorial. Now in case of 8085, we need to understand that the address and data lines are multiplexed. The lower order address bus is multiplexed with the data bus, and the higher order address bus is not multiplexed. That can be used as it is to form the memory address. So what we need to do is we simply need to pass this through a latch. So this latch is going to give me A0 to A7, and it also gives me D0 to D7 to be used as data bus. So this latch basically functions as a separator of address and data lines. Now after that, in the first case that we take, we have 8K memories. So we have different 8K memories with us. Now we'll need to do some maths here. Now we need to find out address lines in 8K memory. Now 8K memory will have 2 raised to the power something should be equivalent to 8K. Now we need to refer that table to find out the number of address lines. Now if you refer to that 2 raised to the power table, we'll find that this question mark is 13. So an 8K memory will have 13 address lines. So all these memories of 8K are going to have address lines from A0 to A12. That will be the case with each one of them. They will have 13 address lines from A0 to A12. Now what we need to do is we need to assign A0 to A12 from microprocessor to these address lines. So what I do is, symbolically I connect A0 to A12 to these address lines. So my 13 lines are used now. A0 to A12, 13 address lines are now utilized. Now I am left with A13, A14, A15 and A16. I'm left with only 3 address lines, 13, 14 and 15. We have a total of 16 address lines here. So these address lines are coming from microprocessor. Now what we need to do next here is, we need to figure out a mechanism by which we can select these memories using these 3 lines. For example, A0 to A12 are physically connected, but at any point in time only one memory is going to be selected by the microprocessor, and that can be achieved by connecting the remaining of the address lines with a decoder. I'm going to use a 3:8 decoder. These leftover lines are connected to 3:8 decoder, and they give me 8 outputs from X0 to X7. Now if we draw a table of A15, A14 and A13 for all the possible 8 combinations, the output which is selected is X0, X1 till X7. Now what I do is, when I specify a 0, 0, 0 here, X0 is activated, and I connect X0 with the enable pin of the memory. So in other words, from the point of view of microprocessor, if a 0, 0, 0 is given on A13, 14 and 15, memory 1 is selected, and if I label all these memories as memory 1, memory 2, so on up to memory 8, all these memories can be selected by specifying a unique combination of bits at A13 to A15. So we have a mechanism by which we can select each of these 8 memories by specifying a unique code on A13, 14 and 15 via a 3:8 decoder. Now at any point in time, only one memory can be selected, because whenever we specify an address, the value of A13, 14, 15 is going to be unique. So that makes sure that only one memory is selected at one point in time, and the remaining address lines from A12 to A1 are used to physically connect with the memory. Now to devise a memory mapped table of the addresses, what we do is we write down all the address lines These 13 address lines are directly connected to the memory, and then we have 13, 14 and 15. That's the way how we write. We draw a line separator here and we'll write to memory, and we write this to decoder. So now what we do is we say for memory 1, to select memory 1, we must select 0, 0, 0 here. Whenever 0, 0, 0 is there on 13, 14 and 15, memory 1 is selected. A 0, 0, 0 here means X0 is activated, which activates memory 1. And memory 1 has physical locations ranging from all zeros to all ones. From the discussion in the previous tutorial, we know that each memory has their addresses from all zeros to all ones. Now we need to populate this table for every memory that we have connected. Memory 2 will be selected when a 1 is given on the 13, 14, 15 lines. 3 is selected when 2 is given. 4 is selected when 3 is given. 5 is selected when 4 is given. 6 is selected for 5. 7 is selected for 6 and 8 is selected for 7. And each of these physical memories, they'll range from all zeros to all ones. So you can populate this table on your own. That is how you make a table. Now, in order to generate their hexadecimal addresses, which is pretty simple enough now, we'll make a pairing of 4. So the first memory address will have a hexadecimal address from 0000H to 1FFFH. and the second memory will start from 2000H and go up to 3FFFH, and the third will start from 4000 and go to 5FFFH and 6000H to now you can see all the memories have been assigned, or the 64K memory space is divided into 8 parts, 8 equal parts. The 64K memory space that starts from 0000 and ends at FFFFH is now equally divided into 8 parts. Now if microprocessor sends data to some random location A, B, C, D, H, you can very well tell that this location lies in memory 6. If microprocessor sends the data to some arbitrary location 1, 2, 3, 4H, you can tell that this lies in memory 1. So any 16-bit data, any 16-bit address that microprocessor addresses to will surely lie in one of these memories, and it becomes easier to figure out which memory IC is microprocessor referring to. So that is how you make a table of addresses by interfacing smaller chunks of memories with 8085, and similarly you can interface 16K memory ICs. They'll have, you can maximum attach 4 ICs because the maximum capability is addressing capability of 8085 is 64K. So you'll be left over with only 2 address lines here, which will be connected to 2:4 decoder, and they'll be used to drive 4 ICs of 16K. But if you want me to present you in detail the 16K memory into 4 ICs as a video, then please leave a comment in the comment section below. And I hope the interfacing memory chunks with 8085 tutorial was helpful. And if you found this tutorial helpful, then please consider subscribing this channel. Thank you so much for watching this. Have a good day and a good life. Bye.